Hello everyone, welcome back to this amazing YouTube channel of Infinity Learn by Sri Chaitanya. I am your host and host, and guys, I welcome you all for the paper discussion of your LTC AIIMS chemistry for weekend test 14. So guys, let's not waste much time and quickly start the discussion of the question that came in this particular paper. So the first question that came in the paper was acetylene undergoes addition reaction with, and these are the four options. So they are talking about addition reaction. Okay, but if you carefully analyze the option 2, option 3 and option 4, all these three options are related to the acidic character of acetylene. Okay, or acidic nature, I can say. In spite of acidic character, we can say it represents the acidic nature of what? Alkyne, right? And since it represents acidic nature of alkyne, this 3 cannot be the answer, and hence the only option that remains is what? Option number 1, and hence that's the right answer. Okay, so question number 51, right option is 1. Now question number 52, diborane reacts with ammonia at high temperature, and the temperature specified is 200 degrees Celsius to form. Remember, it forms boraxene, which is also known as inorganic benzene, which is also known as what? Inorganic benzene, in which boron and nitrogen are present at alternate position, and hence its general molecular formula becomes B3N3H6. Clear? So if I want to show this reaction, the reaction goes in this way: 3 moles of B2H6, that is diborane, reacts with 6 moles of ammonia, okay, to give you 2 moles of B3N3H6 plus 12 moles of hydrogen. Okay, so this is the particular reaction, and the only place where you can see B3N3H6 and hydrogen is option number 2, and hence option number 2 is your right answer. Okay, clear? 53, borax is Na2B4O7 10H2O, right? And kernite is Na2B4O7 4H2O. So these are the molecular formula, or these are the what we say, hydrates. Okay, 10H2O and 4H2O, hence the option will be what? Option number 4. You have to remember this thing, memory based. Next, 54, regarding orthoboric acid, the incorrect statement is, what we need to know is incorrect statement. So orthoboric acid, the incorrect statement: hybridization of boron is sp2, that is true. It is the hydrolysis product of diborane, that is true. It gives metaboric acid as the final product of very strong heating, that is wrong. It gives you boric anhydride. On strong heating, orthoboric acid will give you what? Boric anhydride, that is B2O3, and hence option number 3 will be the right answer. Okay, then option number 4, incorrect statement among the following about gallium is: its boiling point is very low. Wrong. Its melting point is very low, but its boiling point is pretty much high. So I'll go with option number 1 itself. I'll not go beyond that. I got the answer. Let's proceed further. Next, 56. Okay, the reduction potential is positive, right? That means a very good oxidant. Okay, then thorium triiodide is highly stable. That is wrong. So the first one is true, second one is false. So statement 1 is correct, statement 2 is incorrect. Okay, so option number 2 is the right answer. 57, transition metal ions can be detected with the help of a borax bead test. Formula and color of the bead formed by cobalt compounds in this test is, see, you should remember this borax bead test, the formula and the color, and since it is cobalt, it has to be blue color. Since it is cobalt, it has to be what? Blue color. Okay, and its formula is CO. Its formula is CO. Still, I'll show you the reaction, exactly how the reaction proceeds. Okay, so Na2B4O7.10H2O. If you will heat it, it will get dehydrated. That is Na2 will get Na2B4O7 plus 10H2O. Okay, which on further heating, okay, which on further heating will give you 2 moles of NaBO2 plus boric anhydride, that is B2O3. Okay, clear? So this is what borax bead. This entire stuff is known as what? Borax bead. Okay, which is a transparent kind of it. It looks like a bead. Okay, then if we'll further heat it with cobalt oxide, you'll get CO, BO2 twice this. I am showing you over the reactions, entire reaction, but trust me, it is not required from your side to remember it. What is required is the bead is this, borax bead, transparent bead is this, and the color is this. And there are some other colors mentioned in the NCERT book that you have to remember. So we'll go with blue color, that is option number 4. See, 2 and 4 are the same thing, but the molecular formula is different, and hence we'll go with option number 4. 57, option number 4 is the right answer. 58. The number of BB bonds in the structure of diborane. So diborane is hydrogen, 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 hydrogen. So if you see BB bonds, there are 0. So option number 2 is the right answer. 59. How many elements of group 13 forms amphoteric oxide? 2. Aluminium and gallium forms amphoteric oxide. Right? So 2 is the right answer. That means option number 1 is the right answer. 60. Consider the reaction. Okay, this is an alkene, that is ethene, undergoes reacts with KMnO4 in the presence of base at low temperature. So this is nothing but Bayer's reagent. This is what Bayer's reagent, and Bayer's reagent is used to prepare vicinal diol. So the product X over here will be what? CH2OH and then CH2OH. The IUPAC name of the product is what? Ethane 1,2 diol, that is option number 1. Clear? So 60 is option number 1. 61. Tollens reagent can be used, cannot be used to distinguish. Tollens reagent is used to distinguish terminal alkynes and non-terminal alkynes. Okay, so you cannot distinguish ethene, you cannot distinguish ethane, but yes, ethyne can be distinguished and 2-butene can be distinguished because it is used to distinguish between terminal and non-terminal alkyne. Ethyne is terminal, whereas butene is non-terminal, butene is non-terminal alkyne. Hence A and B should be the right answer, and that is option number 3. So option number 3 is the right answer. Okay. 62. Methanol is one of the oxidative ozonolysis product of. Okay, sorry, reductive ozonolysis, extremely sorry, reductive ozonolysis product of. So we have to find methanol, and we know that methanol can be formed if it has CH2 group. So the structures having CH2 group will be the answer. So 2-methyl propene. So let us mark 2-methyl propane. So CH3, CH3, double bond CH2. The first structure itself has what? CH2 group, and hence that will be the right answer. So option number 1 is the right answer. Okay, simple. If you want to prepare methanol, this group is compulsory and it has this group, and that will be the answer. Okay, rest none of will have this CH2 group. You can try it. 63. Hydrolysis of calcium carbide gives an organic compound P. Regarding the compound P, the incorrect statement is hydrolysis of calcium carbide, that is CaC2. If I do the hydrolysis, we know that it is one of the industrial method to prepare acetylene. It is one of the industrial method to prepare what? Acetylene. Right? The incorrect statement, you have to say incorrect statement. It contains same number of sigma bonds as calcium carbide. If you take calcium carbide is this structure. Okay, clear? So this is calcium carbide structure, right? So if we'll see how many sigma bonds are present, there is only 1 sigma bond. But if we'll see over here, there is how many sigma bond? There is 3 sigma bonds. So they definitely don't have same sigma bonds. It contains same number of sigma bond. Answer is wrong, absolutely wrong. So that is incorrect statement. Option number 1 will be the right answer. So question number 63, option 1 is the right answer. 64. X in the presence of zinc and ethanol heated gives you acetylene. So X should be what? It is pretty much clear that this is one of the methods of preparations of acetylene, and acetylene can be prepared in the presence of zinc and ethanol, and X has to be tetrahalide. Tetrahalide of the type 1,1, 2,2 halo compounds like this. and since it is acetylene, this both has to be hydrogen, right? So it has to be a tetrahaloalkane. Option number 4. I'll go with option number 4. 65. X alcoholic KOH give you Y. NaNH to give you acetylene, right? So basically it is what, whether it may be a geminal dihalide or it may be a vicinal dihalide, because this is one of the methods of preparations of alkyne from dihalides. Regarding this process, the incorrect statement is, they are talking about incorrect statement. So regarding this process, X can be 1,2 dichloroethane. True, this is true. NaNH2 is a stronger base than alcoholic KOH. True. IUPAC name of Y is ethylene ethynyl chloride. Wrong. IUPAC name, the structure that we will be getting over here after the first elimination is this, and the IUPAC name is chloroethene. The IUPAC name is what? Chloroethene, not ethynyl chloride. So that is the right answer. So option number 65, question number 65, option 3 is the right answer. 66. CH2, okay, CH2 is brominated, so A will be CH2, Br, right? That is A. Then it undergoes alcoholic KOH and NaNH2. That means what? The B that you are getting is, it will be a triple bonded structure, that is acetylene. And on hydration, this is hydration, and we know that hydration gives you what? Acetaldehyde. If you do the hydration, right, the compound C is acetaldehyde. That is option number 1. Okay, that is what? Option number 1. Clear? 67. Which of the following compound is most acidic? Most acidic, it has to be a terminal alkyne. Terminal alkyne, terminal alkyne, terminal alkyne, terminal alkyne. All are terminal alkyne. But over here, see, can I say this is plus I group, right? And plus I decreases the acidic strength. Again plus I decreases the acidic strength. Again plus I decreases the acidic strength. No plus I. And hence this will be the right answer. So option 60 is question number 67. Option 3 is the right answer. Okay. 68. The following compound is not possible with the formula C4H6. Cycloalkene is possible. See, we can draw cycloalkene like this. Cycloalkene. Wait. Yeah. Cycloalkene is possible like this. Cyclobutadiene is possible. So this is possible. Isolated diene. Isolated diene is a diene in which two double bonds are at least separated by one single bonded carbon, or two sp2 hybridized carbon atom is separated by at least one sp3 carbon. So total number of carbon that is required is 5. We have 4, and hence isolated diene will be the right answer. This is not possible. 68. Option number 2 is the right answer. 69. Consider the following reagent or catalyst used in the various chemical reactions of alkanes. The product is an alkane when catalyst or reagent use this. So if you use first one, you will get benzene. So this is not the right answer. HCl in anhydrous AlCl3 is isomerization. So an alkane will again give you an alkane but an isomer product. So that will be the best answer to select. So 69, option number 2. Clear? If you oxidize an alkane, it will give you methanol. Like for example, methane will give you methanol. And if you oxidize in the presence of KMnO4 with the 3 degree hydrogen, it will give you alcohol. So these two are what? Not the right answer, because they are not giving you alkane back. Only HCl in anhydrous AlCl3, which is an isomerization reaction. Okay, so if you take butane, it will give you isobutane. So alkane giving an alkane, and that is the question that is all about. So 69, option number 2. 70. N-butane can be obtained by decarboxylation. We know that in decarboxylation, the number of carbon atom decreases by 1. So if it is N-butane, we need to start with pent. That is pentanoate. So answer has to be 70, option number 2. Okay. Then, rusting of iron is an example of moderately slow reaction. Very slow reaction, this can be the answer. Instantaneous reaction, ionic reaction. I'll go with option number 2, very slow reaction. 72. The temperature can influence all the following except activation energy, because activation energy can be influenced by nature It can be influenced by the nature of reactant or by the catalyst. Okay, this two can what influence activation energy. So 72, option number 3 will be the right answer. 74. For a particular reaction, concentration of reactant A changes from 10 to 9. So 10 to 9 molar, 10 to 9 molar in 10 minutes. And the concentration of reactant A changes from 9 molar to 8.1 molar again in 10 minutes. Right? Clear? So what will be the order of reaction? It is clearly simple that what will be the order of reaction over here? The order of reaction will be the first order direct. Okay, so hence the option will be what? Option number 1. Very simple. Clear? 74. The rate constant, rate constant of a first order reaction is this. K value is given. Time taken for the completion of 87.5%. So we know that T half, that is equal to 2. You can take it 0.5 or you can take it 50%, whatever you can take. Either you can take 0.5 or either you can take 50%. It's one and the same thing. It is nothing but for first order reaction is 0.693 by K. Right? So that is equal to how much? 0.693. Rate constant that has been given is 0.03. 0.03465. So 35, I can take 0.465 at 0.035 and this I can take as 0.7. So it is exactly double. It is exactly double of it, right? So can I say it is approximately, I'll take it approximately as 20 minutes. Right? So approximately 20 minutes. So see, from T to T half, it is one time. From T half, that is 50%. That is nothing but what? 50%. From T half to T75, that is, if I'll go one more short, so it will be what? Around 75%. It is second. From 75 to 87.5%. That means we are doing half. That means we are doing what? Half. So how much time is required? Can I say it is multiplied by 3? So T half multiplied by 3 will give you what? T 87.5%. So T half is 20. 20 into 3 will be giving you how much? 60. So answer has to be 60 minutes. Let's check. 74, option number 2. Perfect. Clear? Sure. 75. For a reaction, 2A gives you B. What will be the rate of reaction with respect to A if the rate of appearance of B is 0.1 molar? So rate of reaction, can I say it is minus half concentration of A by dt, that is equal to D concentration of dt. Rate of appearance is how much? 0.1 mole. So with respect to A, what will be the rate of reaction? Again, it is 0.1 mole. So I'll go with option number 4. Yep, that's the right answer. 75, option number 4 is the right answer. Clear? 76. Consider the following reaction and identify the correct statement. So zero order reaction, first order reaction. Both reactions can go to completion. Wrong. Zero order reaction, zero order reaction can go to completion, but first order reaction cannot go to completion. The time required to complete the reaction is infinity. So it can go to completion, but this cannot go to completion. Reaction A cannot go to completion. This is wrong. This is wrong. Reaction A can go to completion, true, but reaction B cannot go to completion. That is also true. And in 76, I'll go with option number 3. I'll go with what? Option number 3. Clear? Sure. Perfect. 77. For the reactant A giving you product, rate becomes half the initial rate when the concentration is doubled. Rate become half and the concentration is what? Doubled. So can I say that rate, and we need to calculate order. So can I say rate is directly proportional to concentration raised to its order n. Clear? So rate becomes half. So can I say it is half? Concentrations become double. So concentration will become what? 2 raised to n. So can I say it is 2 raised to minus 1 is equal to what? 2 raised to n, and hence n is equal to what? Minus 1. Right? Option number 1, 77. Option number 1 is the right answer. Okay. 71. Regarding molecularity, the incorrect statement is it cannot be a fractional. That is true. It is for the overall complex reaction. Wrong. It is for elementary reactions. Okay, it is for what? Elementary reaction. It cannot exceed 3. True. It is reduced from the reaction mechanism. True. And hence the only option that is incorrect is 2. So 78, option number 2 is the right answer. 79. T 75% by T 50% for a first order reaction is T1. Okay, T 75 by T 50 for the first reaction is T1. So let us mark this in T 75 by T 50. Okay, is equal to what? T1. Okay, and T 75 to T 50 of a zero order reaction is T2. What is the ratio of T1 and T2? Clear? Sure. So for first order it is very simple. From T50 to T75, from T to T50 is 1, and from T50 to T75 it's 2. So can I say that it is 2 by 1? That means T1 is equal to 2. We got the T1. Then T75 by T50 is equal to T2 for zero order. For what? Zero order. But for zero order we know that X is equal to K times T. X is equal to what? K times T. So with this thing, can I say that X1 by X2 is equal to what? T1 by T2. Clear? That T1 is nothing but T75 by T50. Can we take that thing as right? What will be X1 then? So can I say that 75 by 50 is equal to T75 by T50? That will be equal to how much? 0, 50, that is nothing but 3 by 2. 25 3 is 75, 25 2 is 50. So that is nothing but T2. Now what they have asked is T1. What they have asked is T1 is to T2. Right? So T1 is 2. Whole divided by 3 by 2. So that is equal to 4 is to 3. So answer has to be 4 is to 3. Yes, that's the right answer. Question number 79. Option number 4 is the right answer. Okay. And then 80. A first order reaction can be biomolecular. Okay. That is true. If we take the second component in excess. Radioactive disintegration follows first order kinetics. Okay. So that is also what? True. And hence option number 1 is the right answer. Okay. 81. Reaction is A plus 2B gives you AB2. The experimental data is given as follows. Order of reaction is. Okay. So to solve this thing, let us take experiment 1 and 2. I'll take experiment 1 and 2. If I'll take experiment 1 and 2, let us take order with respect to A. Okay. We'll take order with respect to what? A. So if we'll see concentration of A is doubled. Concentration of A is what? Doubled from 0.025 to 0.05. Okay. Clear? And then concentration of B is same. No change in concentration. Whereas rate is also same. Whereas rate is also what? Same. So there is no change in rate. There is no change in concentration of B. Right? So with this thing, okay, with this thing, can we say that 2 raised to n, that is concentration of A raised to n, and concentration of B is what? Exactly the same thing. So even if I take the ratio, it's one and the same thing, is equal to what? Rate. Okay. And it is equal to what? Rate. That is equal to what? 1. Because again the rate is not changing. So if I take the ratio of the rates of both the things, B and B will get cancelled and rate is equal to what? 1. Right? And we know that anything raised to 0 is 1, so can I take 2 raised to 0, and hence n is equal to 0. That means order of reaction with respect to A is 0. Order of reaction with respect to A is what? 0. Now let us take experiment 1 and 4. I'll take experiment 1 and 4. According to 1 and 4, if we'll see that concentration of A goes to 4 times, okay, it has increased 4 times. Concentration of B has increased how many times? 3 times. And rate has increased 9 times. So with this thing, if I take again the ratio of the rates, can I say it is 4 raised to n into 3 raised to m, that is order of reaction for 3, is equal to rate is how much? 9. Okay, but n value is 0, anything raised to 0 is 1, so that is 3 raised to m is equal to 3 square, that is 9, so m is equal to 2. So order of reaction with respect to B is 2. So total order of reaction, okay, total order of the reaction will be what? 2 plus 1 is 0, 2 plus 0 is what? 2, and hence the answer will be 2. Got it? Clear? So that's the answer. 82. Consider the zero order reaction A gives you B. Okay, consider the zero order reaction A gives you B. If A is the initial concentration and X is the amount of A reacted in time T, then the slope of the graph plotted between A minus X on y-axis and T on x-axis would be. Okay, so for zero order, the equation is A minus, the equation is, A minus X is equal to K times T. Clear? So what we want, A minus X on y-axis, so I'll take A minus X over there and bring KT over here. So A minus KT is equal to A minus X. So this value corresponds to y-axis. Okay, this corresponds to x-axis. So can I say it is mx minus C? So m is equal to what? Minus k, and hence the option will be what? Option number 1. Okay, so 82, option number 1 is the right answer. 83. Which of the following relationship is always true for a second order reaction where A is the initial concentration and T 0.5 is half-life? Okay, clear? So T half, okay, T half is directly proportional to A raised to 1 minus n. Okay, for second order. Since second order is n, can I say that T half is directly proportional to A minus 1. Again, can I say that T half is directly proportional to 1 by A? Right? Clear? And another last thing, A into T half is again equal to what? A constant, because if I remove the proportionality sign, it will get converted to what? Constant. So T, and over here T half is given as what? T 0.5. So A into T 0.5, this is the equation, that is equal to constant, and I can see in option number 2. 83. Okay, clear? Now 84. In a chemical reaction, the temperature coefficient will be least in the temperature range of, okay, so temperature coefficient we need to calculate, and it has to be least in the temperature range of. So hope you remember this equation, log of K2 by K1, okay, log of K2 by K1 is equal to EA 2.303 R into T1 minus T2, T2 minus T1 upon T1 T2. So if you'll see the difference it is 280 Kelvin minus 290, so 10, 290 to 300, 10, 10, 10. So this entire difference is how much? 10. Okay, so log of K2 by K1 is equal to EA 2.303 R into 10 into T1 into T2. So with this equation, can we say that log of K2 by K1 is is inversely proportional to product of T1 and T2? Yes or no? Temperature coefficient will be least. Okay, temperature coefficient. So this is the temperature coefficient. It will be least when the temperature range will be maximum. So if we'll increase this thing, this will decrease. Hence the maximum temperature range is 310 to 320. That will be the answer. Okay. 85. Propene on ozonolysis gives A and B. So if I take propene, that is CH3, CH double bond CH2. So if we'll break this thing, oxygen and oxygen, that is acetaldehyde plus formaldehyde. Ethene gives you A. That means A are both same. So if I take ethene, CH2 double bond CH2, you will get 2 moles of HCHO. That is, you have to break and add oxygen. So this is A. This is also A. Incorrect statement among the following. Okay, and this will be B. B is ethanol. Wrong. Both A. Wait. B is ethanol. That is right. Extremely sorry. B is ethanol. We need to identify incorrect statement. B is ethanol. Correct. Both A and B have alpha hydrogen atom. Incorrect. Because A does not have alpha hydrogen. So that will be the right answer. 85, I'll go with option number 2. 86. C2H5Cl, sodium ether. This is Wood's reaction. You will get what? CH3, CH2, CH2 and CH3. That is A. Right? Then you are doing what? Bromination. It will give you a stable product. And the stable product is 2-bromo-butane. So that is what B. Okay, and B is major, so we have taken stable product. And then you use a bulky base. This is what bulky base. And bulky base is responsible for Hoffman's elimination. It is responsible for what? Hoffman elimination. And if I talk about Hoffman elimination, it will give you a product C double bond C, a terminal alkyne. And I can see only option with the least stable alkene is option number 2. So 86, option number 2 is the right answer. Okay. 87. Alcoholic KOH will give you elimination. So the product will be looking something like this. Then add HBr, that is Markovnikov's rule. So the product will be looking something like this. Alcoholic KOH, again, it will give you E2 mechanism and double bond. So trans-butene will be the major product over here. The following compound is the positional isomer, but not the chain isomer of but1-ene, because this is but2-ene, this is but1-ene, and hence that will be the right answer. See. Okay, clear. 88. 2-but2-ine, Lindlar's catalyst, it should give you cis-but2-ene. Burst reduction, it will give you trans-but2-ene. So the structures will be like this. Cis is this, or you can take this as a structure, whatever it is, and trans is this. So what is the option? Cis trans, option number 1 seems to be the right one. Okay, 88 is done. 89. Ethene forms an unstable compound. Unstable compound when it reacts with chlorine, it will give dichloroethane, stable. Dibromoethane, stable. Iodine, to iodines is bulky molecule, so this will be unstable, and the last one is hydrogenation. So out of all, the most appropriate answer will be option number 3. Okay, so we'll go with option number 3. So 89, option number 3 is the right answer. Now 90. Vicinal dibromide, that is nothing but 1,2 dibromoethane, is been treated with excess of NaNH2. Excess of NaNH2, which will give you a double elimination, and hence the product will be and CH3Br in excess. If I take CH3Br in excess, both the hydrogens will get replaced by CH3Br and will get but2ine. Positional isomer of the compound is positional isomer, that means double bond will be shifting. This should not be the answer, and this should not be the answer, and this should not be the answer, because one is the same one. 2, I can say the triple bond position has changed. It is but2ine, this is but1ine, and hence the right answer is option number 2. 91. Bayer's reagent can be used to distinguish. Bayer's reagent is used to distinguish saturated and unsaturated hydrocarbons. So ethene and ethane, yes, it can be distinguished. Ethene and ethane can be distinguished. So A and B, do we have A and B? No, we don't have A and B. Ethane and ethine, yes, this also can be distinguished. This can also be distinguished. This can also be distinguished. Do we have answer? Do we have answer B and C? Yes, option number 4 is the right answer. Okay, one more thing. See, option number, fixate on option number 3, A and E. A and E. This cannot be distinguished. Okay, because over here distinguishing test means what? That you can see it from your naked eyes. That means that you can see it actually. Both ethene and propene will decolorize. But if we talk about B and C, A will not decolorize. The color will still remain the same. Whereas ethyne will decolorize Bayer's reagent. That pink color will get changes to, or violet color will get changes to colorless. Okay, so that's why I've selected option B and C. 92. 4-methyl pentoene. 4-methyl pentoene when heated with acidified KMnO4. So 4-methyl pentoene. 4-methyl. It will give you what? This will get converted to acid. This will also get converted to acid because they both have hydrogen. So over here hydrogen will get oxidized. Over here also hydrogen will get oxidized. So in actual case what happens? You will get 2 moles of carboxylic acid. Not the same carboxylic acid, but the different carboxylic acid. So 1 mole of each carboxylic acid and ketone, not the right answer. 1 mole of each carboxylic acid and aldehyde. Aldehyde cannot be formed in KMnO4. 2 moles of carboxylic acid seems to be right. So 92, option number 3 is the right answer. 93. The correct statement among the following about 13th group element is: the element with the highest density is thorium. Okay, the element with the highest density is thorium. True. The element with highest boiling point is thorium. False. We need to identify what correct statement. Okay, the element with least ionization potential is indium. False. The element with least electropositive nature is indium. Okay, wait. The element with least ionization potential is indium itself. Okay, it is indium itself. True. And the element with least electropositive nature is indium. That is false. So option A and option C is the right answer. That is option number 3. Clear? Sure. Perfect. Now 94. Most electropositive element of 13th group. Most electropositive element of 13th group is aluminium, because it is least electronegative, and boron is highest electronegativity in 13th group is aluminium. So we have identified this is what aluminium. Regarding X, the correct statement is, we have to identify correct statement. It shows stable +1 state in compounds. Wrong. It is the most abundant element in the earth crust. No, it is the most abundant metal. It has maximum covalency of 4. No. It can react with both acid and alkalis. True, because it is what? Amphoteric in nature. So that will be the right answer. 95. For the reaction, A gives product. Concentration of A changes from 1 molar to 0.6 molar in 20 minutes and 0.6 molar to 0.2 molar in next 20 minutes. Okay, the first decrease is how much? The first decrease is how much? 4. And the next decrease is also how much? 4. See, 1 molar to 0.6. What is the change? 0.4 molar, and then 0.6 molar into 0.2 molar, again 0.4, and the time taken at both the time is what? 20 minutes and 20 minutes, and hence this is very simple, and it gives us which reaction? It gives us which reaction? Zero order reaction. As simple as that. Okay, 95 is 3. 96. Consider a gaseous reaction A gives you 4G. Okay, 4B. Okay, the initial pressure of A is P0 mm of Hg and the total pressure after time T is Pt. Okay, if the reaction follows first order kinetics, they have given first order kinetics, the correct expression for the rate constant will be. So let us start. See A, wait a sec, yeah, let me mark it over here. So the question is A gas will give you 4 B gas. Initial pressure is how much? Initial pressure is what? P0, and there is no product form, so no initial pressure. Pressure after time T, it will be how much? P0, suppose X is the pressure change. Okay, clear? So this will be what? 4x. So what is total pressure after time T? Total pressure after T is equal to how much? P0 minus X plus 4x, that is equal to P0 plus 3x. Okay, and the total pressure is Pt, that is equal to P0 plus 3x, and hence X is equal to how much? Pt minus P0 by 3. So initial pressure is P0. Pressure after time is this Pt minus P0 by 3. Okay, so P0 P0 minus Pt minus P0 by 3 will give you how much? It will give you 3P0 minus Pt plus P0 by 3, that is equal to 4P0 plus Pt by 3. So this is the total pressure after time T. Okay, this is minus Pt. Wait. Okay, now K is given as 2.303 by T log of initial pressure. Log of initial pressure is how much? P0 by final pressure. Final pressure is how much? 4 P0 by T whole divided by 3. So what will be the final equation over here? K is equal to 2.303 by T log of 3P0 whole divided by 4 into P0 by Pt. So this will be the final answer. Okay, this is what the final answer. And where can we see this thing? So option number 3 is right. 2.303 by T log of 3P0 4P0 minus Pt. Yes, that will be the right answer. Option number 3. Okay, clear? Then 97. Identify the correct statement. We need to identify the correct statement. Units of rate of second order reaction is this. You can say all the reaction follows this thing, so we'll not take this. Rate constant for a reaction does not vary with concentration changes of reactant. That is true, we can say. Catalyst increases the magnitude of rate constant of the reaction. That is also true. So I'll go with option B and option C, and that can be seen in option number 2. So that is the right answer. 98. In the first order reaction, X changes to Y. Rate constant of the reaction is this. Time taken for 80% of the reaction to get completed. Okay. So time taken for the 80% reaction to get completed. Let us calculate this value. So K if I want to for first order reaction, K is equal to 2.303 by T log of A by A minus X. Okay, rate constant is given as 6.99 into 10 raised to minus 2, that is equal to 2.303 by T log of, okay, log of A minus X. Okay, so A is how much? 100%. Okay, completed is how much? 80%. So that is 100 minus 80 is how much? 20. Right? So if we'll solve these things, okay, if we'll solve this thing, we'll get time is equal to 23.03. Okay, and hence option number 2 will be the right answer. 99. The reaction X gives you Y for zero order kinetics. Zero order kinetics is given. Initial concentration of X is 4m. Concentration of Y after 30 minutes is 3m. Rate constant of the reactant. So this can, for a zero order, X is equal to how much? X is equal to K times T. Right? That will be K is equal to how much? X by T. X is how much? Its concentration is how much? 3. Right? Whole divided by time is how much? 30 minutes. Right? So that will be how much? 0.1. So that will be 0.1. Answer is 0.1. 100. Hydrolysis of ethyl acetate carried out in acidic medium is an example of pseudo first order reaction. Units of the rate constant for pseudo first order reaction will be, okay, so hydrolysis of ethyl acetate, that is nothing but an ester. So ethyl acetate, that is CH3 COO C2H5 plus, if you do hydrolysis you have to take water in excess, it will give you what? CH3 COOH plus C2H5 OH. Okay. So if you calculate K is what? Concentration of K is what? Concentration of this, that is CH3 COOH into concentration of C2H5OH whole divided by CH3 COO C2H5 into concentration of what? H2O. Clear? This is what? This is what equilibrium constant. If I want to calculate rate constant K, so K will be equal to, rate of the reaction will be equal to K times concentration of CH3 COO C2H5 into concentration of H2O. Now concentration of H2O is not going to change. It is a solvent and it is taken in excess, so this is not going to change. Constant, K is constant, H2O is constant, so it will give rise to a new constant, that is K dash into CH3 COO C2H5. Clear? Sure. So K is equal to what? K is equal to K, that is the first order constant whole divided by concentration of water, that is equal to, for the first order it is time inverse whole divided by concentration of water is what? Mole per liter. Clear? So what will be the final equation? What will be the final unit over here? Liter will go up, okay, then time inverse and then mole inverse. So this will be the concept. Okay, clear? So what is the answer over here? Liter, time inverse, mole inverse. So time inverse and mole inverse. So liter, time inverse, mole inverse. So option number 3 will be the right answer. Okay, because mole per liter is nothing but what? Molarity. So this is what? M minus 1, molarity inverse, and then time inverse. That is the concept. Okay, clear? Sure. So guys, that's the concept. That was the question that came in your LTC AIIMS weekend test 14. So I hope you must have understood all the solutions of the question that was discussed in this particular paper. With this thing guys, thank you so very much for joining. God bless you all. Keep smiling and all the best for your all upcoming papers. Take care guys.